Okay, so when we have a set of data and we're making a scatter plot and we want to use a regression line to, model the data, we have to be careful to make sure that we use the regression line within a reasonable range of values. In other words, we don't want to do what's called extrapolate, meaning that we're not going to use the regression line to make guesses for values that are far, far away from the set of values that we have information on. For example, like let's see, let's take for example, when you usually when you start a sport, let's say you're starting track or starting running. I actually did track way back in the day, I did track, ran distance, did cross country. And for when you first start, you can barely run, 2 miles without, dying. Like the first month, you're going from the first day of practice, which is like 10 minutes of running and you're like pretty much already dead, to like being able to run, 7, 10 miles, within a few months. And I remember that, like, when I first started, like my races where we were racing 3 miles, I would improve my race time each week by like 20, 30 seconds. Like the first season, I improved by probably a few minutes. Like I don't even remember how many, maybe like 2, 3 minutes. But the next year, now that I was very experienced, I probably only improved by maybe 30, 30, 45 seconds over the entire season, meaning that I couldn't I couldn't use that that same rate of change. In other words, I couldn't basically assume that I was going to continue to increase by like 10, 20 seconds each race. I wasn't going to be able to get that much better each time because now that was I was seasoned. So same thing maybe if you're starting weightlifting and you never lifted before, the first month you'll probably be able to lift 20 more pounds than you did, a month before. Then maybe the first 6 months you're able to lift 50, 60 more pounds and you put on like, 10 pounds of muscle. The first year, you get, you like double your strength, you put like 20 pounds of muscle. But the second year, you're not gonna be able to put on that same amount of muscle, unless you're taking steroids or something. But we all know that we're not gonna be able to pack on as much strength year after year. Our rate of increase is going to slow down. You can't expect that. It's just it's just the way it works. And this is a big deal when we're talking about business. A lot of businesses, when they first start up and they're first getting customers and first getting their products sold, they go from the first year making 50,000 to the second year to making 200,000. To this third year they're making 600,000. So they think, oh, we're going to triple in profit every year. No, but we know that it's not going to hold forever. So we call that extrapolation. We're making predictions far outside the range of values that are probably not going to be correct. So we have to always keep that in mind when we're dealing with real life problems. So let's look at what's going on here with Armin. Armin was concerned about the amount of sugar in his diet. So he went to the store and collected data from several cereal boxes and used the data to create a model that relates the amount of sugar in cereal to the number of calories, where we have this equation: S is equal to negative 16.9 plus 0.230 C, where S is the amount of sugar in grams and C is the amount of calories in 1 cup of cereal. All right, so for the first part, we're going to interpret the meaning of the slope and y-intercept in the context of the problem. And does this y-intercept make sense in this context? Okay, so remember the slope is going to be the coefficient of our explanatory variable. Our slope is 0.23. Now remember, like in case you're always, at first my students get confused about how do we, describe rate of y over rate of x. How do we describe how one variable is changing and related to the other? Remember, it's just y over x, and any number can be written as a fraction when you put it over 1. So the change of x, you can always think about it as 1, and the change in y is 0.23. In this case, y is s, And in this case, X is C. So we can say then that for each additional increase in calories, so for each additional calorie, the amount of sugar, S, is predicted to increase by 0.23 grams. Now, let's look over the what about the y-intercept? Now the y-intercept is negative 16.9. And remember, the y-intercept is the value of, the explanatory variable, in this case, the value, the value of y, or the response variable, when C is 0. So it's basically saying that when the calories are 0, there's predicted to be negative 16.9 grams of sugar. And well, obviously that's impossible. You have no calories, you got no sugar. So that wouldn't make any sense in the context of the problem. And now, question B, what does a negative residual mean in this context? Now, remember, residuals basically are values that tell you how off your predictions will be. Now, you can either overpredict or underpredict. And so when the residual is positive, it means that you're predicted over. If the residual is negative, that means that you underpredicted. So in this case, that means that we would have had a guess that would have been less than the actual value. And so that means that, the actual amount is more, and, our guess would, be, again, less than the true value. It would be like under prediction. Again, there's a couple ways of writing your answer. Just make sure you write it in the correct way, because you can write it, saying, oh yeah, that the actual amount is more, or that your guess is less. It's the same thing, but just make sure you write it correctly. Now, question C, should we use our equation to predict how much sugar there would be in a cereal that contains 1,000 calories per cup? Well, this would not be a good idea, because we don't really have information on cereals with that much calories. Those are pretty heavy cereals. So it's a pretty dense cereal. 1,000 calories per cup, that's a lot. I don't know what they're doing with that cereal, but probably wouldn't be a good idea to use this equation, because we don't know if it's even what's similar to how the calories are laid in this one. So we would not do that. The data is very far from what we have information on, and this is an example of extrapolation.